This arc flash hazard awareness training is intended for facilities maintenance mechanics and electricians who may be exposed to live electrical work. Remember, this is only awareness training to address the potential hazards of conducting live electrical work with voltages greater than 240 volts. In most cases, arc flash hazards are more likely to exist when working with 480 volts or greater. This training does not qualify you to perform live electrical work on energized equipment. In order to perform live electrical work, you must receive additional specialized training to be a qualified person. This means you must be knowledgeable on the types of electrical equipment you will be working with and on safe electrical work practices. This includes skills and techniques to distinguish exposed live parts from other parts of electrical equipment, to determine voltages of exposed live parts, and clearance distances for voltages involved. You must also be trained on what PPE is required to protect you from shock and arc flash hazards. Keep in mind that if you use lockout tagout, you will minimize the potential for an arc flash event. Shock and electrocution are recognized electrical hazards when working with 50 volts or more. Arc flash is the other hazard that has received quite a bit of attention since the early 2000s when working with electrical distribution systems and equipment in buildings and facilities. Have you ever shorted out anything and experienced a flash for a fraction of a second? Like using jumper cables, maybe? That's an arc flash where there is not enough energy available to sustain the arc. An arc flash is a short circuit with enough voltage and current to maintain an arc. The duration of the arc depends on the reaction time of the overcurrent protection device, usually a circuit breaker or fuse. Temperatures in the arc can reach 35,000 degrees, resulting in flying molten metal such as copper, aluminum, and steel. The resulting arc flash creates a pressure wave in thousands of pounds per square foot and noise levels that can exceed 160 decibels. So why has arc flash received so much attention? 5 to 10 arc flash explosions in electrical equipment occur every day in the United States. Up to 80% of the electrical injuries are burns suffered from arc flash and clothing catching fire. Polyester cotton blend clothing will melt and stick to the skin, increasing the severity of the burn. Also, 100% cotton, which was thought to provide some protection against arc flash years ago, will in fact burn if there is enough incident energy. Injuries range from minor to third-degree burns and even death. There are 3 work-related deaths each week due to electrocution, which would include arc flash fatalities. The extent of the injury depends on the amount of short-circuit energy available and the reaction time for the overcurrent protection device, such as a circuit breaker or fuse. Reaction time can be from milliseconds to seconds, depending on the type and condition of the overcurrent protection device used. A serious arc flash injury requiring treatment at a burn center can result in medical costs exceeding $1 million. The amount of energy or heat generated from an arc flash is referred to as incident energy and is measured in calories per square centimeter. Holding a cigarette lighter to the tip of your finger for 1 second equals 1 calorie per square centimeter. 1.2 calories per square centimeter will result in a second-degree burn. The arc flash boundary is the distance from the source of the arc where a second-degree burn can occur. The available incident energy determines what PPE is required to prevent a second-degree burn if exposed to an arc flash. Typically, the higher the voltage, the higher the incident energy. However, the clearing time for the overprotection device, whether it be a circuit breaker or a fuse, also affects the amount of incident energy during an arc flash. The 2015 version of NFPA 70E recognizes that for voltages 120 volts or less, there is not enough energy to sustain an arc. Earlier versions of NFPA 70E used 240 volts or less. For most office environments, 120 volts is primarily used, with 208 or 240 volts used for lighting and some types of equipment. Again, for voltages greater than 120 volts up to 240 volts, there is an arc flash hazard potential, but is very unlikely since there probably is not enough energy to sustain the arc. An arc flash incident energy analysis would be required to determine the actual incident energy available for each electrical power distribution device. An arc flash occurs extremely fast, with most less than a fraction of a second for 480 volts or greater. The duration depends on the clearing time for the circuit breaker or fuse to trip and shut off power. The age and condition of the overcurrent protection devices also has an effect on the clearing time. For an aging breaker that has never operated or been maintained, it may not open the circuit, and the upstream overcurrent protection device will have to operate to shut the power off. So what causes an arc flash in the first place? Faulty equipment or broken down insulation and wiring? Maybe, but highly unlikely. A circuit breaker or fuse continuously tripping out would be a telltale sign you either have an overloaded circuit or other problem with the electrical circuit. Most likely it will be a direct short circuit caused by operator interface, such as touching the electrical panel cover, a tool like a screwdriver, or test lead on voltage meter across energized wires, creating a short circuit. Live electrical work must not be allowed, and lockout-tagout is required when performing any type of electrical work. The photo at the top right shows what unprotected live electrical work can look like. I advise you not to put yourself in a situation similar to this, since this panel is most likely 480 volts or more. The only exception to this is when troubleshooting with a voltage meter to determine the problem. Troubleshooting with a voltage meter is live electrical work when an arc flash hazard exists, and appropriate PPE must be used as shown in the photo at the lower right. Once the problem is found, lockout-tagout must be used before making repairs. Does this look safe? This is probably not uncommon in many places where a maintenance person is troubleshooting or working on energized equipment. So what do you think? Probably at a construction site. Most likely in an energized electrical circuit, unless lockout-tagout has been applied to the power source supplying this panel. You can see the exposed bus bars the circuit breakers are mounted to. This is most likely a 120 to 08 volt panel, but if it were 480 volts, an arc flash hazard would definitely exist. I'm showing you this photo to give you an idea how easily a short circuit across hot wires or to ground could happen if you are working on this panel hot or troubleshooting it with a voltmeter. Permission has been obtained from Westex, which is a leading arc-rated fabric manufacturer, to use the following video clips from arc flash tests conducted to demonstrate the amount of energy and force produced by an arc flash in such a short, almost instantaneous period of time. The video clips where mannequins are wearing non-flame resistant clothing is noted as such. This arc occurred in a 30 amp 480 volt disconnect. The incident energy is 1.5 calories per cubic centimeter, which could cause second-degree burns. The reaction time for the overcurrent protection device is 2 cycles, which represents 33 milliseconds. The arc flash event is almost instantaneous.
To arc with polyester cotton shirt and pants. The arc and the clothing is immediately on fire. And not just the shirt, but notice that the pants as well, even though they would not have been predicted to ignite in this arc, they did. And the clothing will continue to burn, dramatically increasing the severity and the extent of the burn injury that would be suffered in this instance. You can see how rapidly as well the fire progresses to the back of the shirt, which would not have been injured in the original arc flash. In slow motion, you have an excellent look. You can see molten metal hitting the lens of the camera from 22 feet away. The camera's 22 feet from this arc, and molten metal droplets are hitting it. Before the molten metal has even completely cleared the air, the garment is on fire. What you're looking at now is fire, not arc. And a clothing fire this violent is going to dramatically worsen injury. We'll get an outstanding look at this again in frame by frame. See the arc coming out and completely enveloping the mannequin. The violence of this explosion. Here comes a arc molten metal droplet that's going to hit the camera. You see the arrow. Hits the lens and spatters. And again, that's 22 feet from the arc. So the molten metal is obviously a significant hazard at a great distance from the arc.
This mannequin is wearing 100% cotton, non-flame resistant shirt and pants. We have an arc and a resultant clothing fire. The pants didn't quite ignite, but the shirt certainly did. This arc was a little bit smaller than would normally be expected to ignite cotton of the weight the pants are. The firefighter has turned the mannequin head on to the camera now, giving you a better look at the extent of the damage. Let's take a look at that again in super slow motion. We have an arc throwing molten metal especially high and toward the camera this time. Also back and to the left of the mannequin. Large amount of molten metal. And as the arc starts to fade and the smoke starts to clear, you see a massive garment fire. It's actually fairly unusual to be able to see the fire that well through the smoke, but this time the smoke stayed low, giving us an excellent opportunity to see just how rapidly this garment becomes fully involved with flame. With this arc, we had a camera positioned directly on top of the disconnect, giving us a head-on look at this arc and fire. Look at that. As the smoke clears, the entire shirt is on fire, waist up. Our firefighters come into the scene and pull the mannequin back. You get an even better look at how extensive and how aggressive this fire is. This mannequin is wearing Westex Ultra Soft shirt, pants, and balaclava. We have a 10-calorie arc and a 480-volt disconnect. And after the arc's over, there's no fire on the garment. You do see some fire in the disconnect. There's something continuing to burn in the disconnect. But the Ultra Soft has done its job. You can see in the still frame here, there's no significant damage of the garment and no break opens. Primarily a upper leg and lower torso event. And we'll get an even better look at that in our 3,000 frame per second split screen. There's a ton of molten metal coming out in this event at significant distances from the arc itself. If you look at the blue wall in the back with the stripes and the numbers, that's 15 feet from the mannequin, and you can clearly see chunks of molten copper hitting that wall through this entire event.
Troubleshooting electrical distribution systems in your building. Arc-rated PPE must be worn to protect you from an arc flash for the available incident energy present as indicated on labels attached to the electrical equipment being serviced. PPE must include arc-rated flame-resistant clothing consisting of pants with shirt or coveralls, balaclava, also known as a sock hood, safety glasses, hard hat with arc-rated face shield, voltage-rated insulated gloves with leather outer glove. Hearing protection must also be worn to protect you from the excessive noise levels during the arc flash blast that occurs. Lockout tagout must be used to make the repairs so live electrical work is not performed. Pictured at the top are both examples of generic arc flash labels. NFPA 70E requires what information must be included on the label. Prior to 2009, the top portion of each were acceptable. Later versions of NFPA 70E required additional information to be provided for the arc flash labeling. If an arc flash hazard analysis has been performed to determine the incident energy available, the electrical equipment should have an arc flash warning label listing the level of PPE required and the incident energy available as shown by the bottom label additions. Most 120-208 electrical panels do not have sufficient energy for a sustained arc to be maintained and will not be labeled. Labeling applies primarily to 480 volt or greater electrical panels. This label meets the 2015 version of NFPA 70E. The following information must be included on arc flash warning labels. Arc flash boundary, at least one of the following. Available incident energy at the corresponding distance. Arc flash PPE category. Minimum arc rating of clothing or site-specific level of PPE. Live electrical work at voltages greater than 50 volts should not be allowed and lockout-tagout must be used. If electrical work cannot be performed safely by maintenance personnel, it should be contracted out to a company with qualified personnel trained in electrical safe work practices for live electrical work. This concludes this arc flash hazard awareness training.